Continuous functions. A function f of x is continuous at x is equal to a if first condition f of a exists, second condition limit x tends to a f of x exists, and third condition limit x tends to a f of x is equal to f of a. So, when can we say a function is a continuous function at x is equal to a? First point, f of a should exist. That means in the place of x, we have to substitute a and then you have to find the value of the function. Instead of x, you have to substitute a, that is only f of a. Second one, applying the limit x tends to a f of x exists. You have to find the left hand side limit and right hand side limit of the function at the given point. Third one, the first two conditions should be equal. Limit x tends to a f of x is equal to f of a. The first two conditions should be equal. Then we can say that the function is a continuous function at the given point. Examine the functions for continuity. First one, f of x is equal to x square minus 4 by x minus 2 if x is not equal to 2. 0 if x is equal to 2. That is the function. We have to check its continuity at x is equal to 2. So, first let us write the function. We have to find, to check the continuity, what we have to do? We have to, for a continuous function, a function f of x is continuous at x is equal to a if f of a exists. The first point, f of a should exist. Then limit x tends to a f of x exists. And the third point, limit x tends to a f of x should be equal to f of a. This should be equal. First f of a should exist, then f of x limit should also exist. Then this two, the first two should be equal. Then we can tell the function is continuous. So, it is given that f of 2 is equal to 0 also, because f of x is 0 if x is equal to 2. We have to find the continuity at x is equal to 2. So, f of 2 is equal to 0. First, let us find the left hand limit. How will you find left hand limit? What is the algorithm? First, we have to write the limit as minus. For left hand limit, you have to write it as a minus. Here we have 2, so x tends to 2 minus f of x. Now, that is equal to limit, okay. In the next step, you have to write x is equal to a minus h and replace x by a minus h. Okay. So, the limit will change. Limit x tends to 2 minus and it will change as limit h tends to 0. F of 2 minus h. Here we have a as 2. So, limit f of 2 minus h. H tends to 0. Instead of x, you have to substitute 2 minus h in the function. That is equal to limit h tends to 0 x square, that is 2 minus h the whole square minus 4 divided by x minus 2. What is our x? 2 minus h minus 2. 2 minus h minus 2. Okay. So, limit h tends to 0 2 square plus h square minus 4h minus 4 divided by minus h, that is equal to 2 square is 4. So, 4 minus 4 will get cancelled. So, in the numerator, limit h tends to 0 h square minus 4h, that is h into h minus 4 by minus h. So h and h will get cancelled, that is equal to limit h tends to 0 minus of h minus 4. While applying h to 0, it will become, while applying the limit, it will become 0 minus 4, that is equal to minus of 0 minus 4. So, minus and minus will plus, that is equal to plus 4. So, left hand limit at x is equal to 2 is 4, but we have f of 2 is equal to 0, but while applying the limit for 2 we get 4. So, these two are not equal. F of 2 and the left hand side limit are not equal. That implies here L of f of x at x is equal to 2 is not equal to f of 2. That implies f is not continuous. It is not a continuous function. Examine the functions for continuity. Second one, B. F of x is equal to x square minus 9 divided by x minus 3 if x is not equal to 3, and 6 if x is equal to 3 at x is equal to 3. Okay. So, what is our function? F of x is equal to x square minus 9 by x minus 3, and it is given that f of 3 is equal to, at x is equal to 3 we have to find f of 3 is equal to 6. Okay. So, left hand side limit L of f of x at x is equal to 3 we have to find is equal to limit x tends to 3 minus, for left hand limit it is 3 minus f of x. On the next step it is limit h tends to 0 f of 3 minus h, a minus h. So, here it is 3 minus h. Okay. So, that is equal to limit h tends to 0 f of 3 minus h. So, we can write it as 3 minus h the whole square minus 9 divided by 3 minus h minus 3. Okay. So, that is equal to limit h tends to 0, we will expand the numerator, that is 3 square plus h square minus 6h minus 9 divided by minus h. 3 square minus 9, here 3 minus 3 will get cancelled. Okay. So, h square minus 6h, that is limit h tends to 0 minus, we can bring the minus to the numerator. So, minus h into h minus 6 divided by h. H and h will get cancelled. While applying the limit, this will be equal to 6. 0 minus of 0 minus 6, and it is 6. Yes, f of 3 is also equal to 6. So, now we can find the right hand side limit. R of f of x at x is equal to 3. Now, we have to find the right hand side limit. Okay. So, limit x tends to 3 plus, for right hand side limit it is 3 plus right hand side. So, f of x, that is limit h tends to 0 f of 3 plus h, not minus h, it is 3 plus h, number line. When we are checking the number line, while going towards right the values will be increased, while going towards left the values will be decreased, isn't it? So, only for the left hand side limit it is minus, and for the right hand side limit it is plus. So, that is equal to limit h tends to 0 f of x, that is 3 plus h the whole square minus 9 divided by 3 plus h minus 9, that is limit h tends to 0 3 square plus h square plus 6h minus 9 divided by, sorry, here it is 3. 3 and 3 will get cancelled, in the denominator it is h. So, that is equal to limit h tends to 0 3 square and 9 will get cancelled, minus 9. So, h into h plus 6 divided by h. H and h will get cancelled. So, it is h plus 6. While h tends to 0, it will become 6. While applying the limit, h tends to 0. So, 0 plus 6, that is 6. Now, we have found that f of 3 is equal to left hand side of f of x at x is equal to 3 and right hand side of f of x at x is equal to 3 are equal. That implies f is continuous at x is equal to 3. So, that f of x is equal to modulus x is continuous at x is equal to 0. What is our function? F of x is equal to modulus x. So, first we have to find L of f of x, that is the left hand side limit, that is limit x tends to 0 minus f of x. In the next step, it will limit h tends to 0 f of 0 minus h, that is limit h tends to 0. What is our function? Modulus x, that is modulus 0 minus x, that is limit h tends to 0 modulus minus h. What is the quality of modulus? If you give the minus values, it will be positive. So, limit h tends to 0, it is h plus h ஆயிடும். So, while applying the limit, it is equal to 0. Now, we can find the right hand side limit r of f of x, that is limit x tends to 0 plus f of x, that is equal to limit h tends to 0 f of 0 plus h, that is h tends to 0 modulus 0 plus h, and that is plus h. While applying the limit, its value is also equal to 0. We have to show that it is continuous at x is equal to 0. So, left hand side limit and right hand side limits are equal, but we should know what is f of 0, that is the function value. The limit value we have found, the function value. The function value f of 0 we have to find. F of 0 means in the place of 0 we have to put, in the place of x we have to put 0. So, f of x is mod x. So, f of 0 is equal to 0. Now, we have found that the left hand side limit, the right hand side limit and the function value are all equal. That implies L of f of x is equal to R of f of x is equal to f of 0. These two are at x is equal to 0. All are equal. That implies f of x is equal to modulus x is continuous at x is equal to 0.